Okay, but everybody here, welcome to the panel. And basically what we're going to do is, before we get started with the panel, I want to just take a look back at the last year of Lakehouse open source. It's been an amazing year seeing these open standards form, creating the backbone of the systems that are powering our AI, our BI, all our workloads. So bottom line is there's three key pillars, because at the end of the day, you need sort of three things to really have a powerful Lakehouse. Okay? You need a good in-memory transport format, because data is moving around. You want to be able to move that data around quickly. You want to be able to process that data quickly, and that's the role of Apache Arrow. Okay? But you also need to be able to organize your data in a way that your different tools can talk to them, give them the ACID guarantees that you would expect when you're working with a normal database or data warehouse. This is where Apache Iceberg comes in. And then you need a metadata catalog. You need some sort of source of truth that tracks, hey, these are the data sets I have available. Here's who has access to them. Okay, to make sure that your data sets are governed, accountable, and auditable. And that's where Apache Polaris comes in. And all three have had a banner year this year. Okay, I mean, you have Arrow kind of continuing, improving its ability to be able to process and move data very quickly with expansions of sort of, the adoption of ADBC. Also, every year you're starting to see more and more languages grow with more Arrow-based libraries. So like reading on the Arrow list, just frequently, like you're starting to see discussion of an Elixir Erlang Arrow library. So just another language where you can really kind of take advantage of this technology. You have Iceberg, which this year codified the V3 of the spec, which brought a lot of really cool innovations. Okay, whether it's like default column values, whether we're talking about binary deletion vectors that are going to make updates much faster and simpler and efficient, or we're talking about new data types like variant and geospatial types. And there's already discussions about what's going on in V4. Okay, anyone who joined me in that presentation earlier where I talked about V3 and V4 got to hear about a lot of the stuff that is coming, that has come, and just sort of the exciting future that Iceberg has. And then we have Polaris. Okay, Polaris becoming the community standard when it comes to a catalog for your Lakehouse. Okay, really hardening and becoming sort of production grade with its 1.0 release. Okay, bringing you governance, the ability to do RBAC on your data sets, being able to do credential vending, so that way you don't have to give all your users a set of storage credentials. Okay, for much more tight-knit security. Okay, expanding now beyond Iceberg and becoming a catalog for your Lakehouse, okay, with a couple different proposals, whether there's a table sources proposal that's currently being discussed, a early stage beta of a generic tables feature. All these tables are going to allow you to take Polaris and go beyond Iceberg, so that way you can have one catalog that manages your entire Lakehouse. Okay, one source of truth. And also the ability to federate catalogs. So that way if you do have other catalogs, that they can all be connected in one place, so that way there's just one pane of glass for your end user. Okay? So it's a breakthrough year for the Lakehouse, okay? Whether we're talking about being able to compute data faster with Apache Arrow, being able to track our tables, and being able to manage our tables with Iceberg, and being able to govern those tables with Apache Polaris. So again, we're aligning data types. So basically some of the things that were happening this year were, one, getting different data types like the geospatial data types, like the variant data type, not just into Iceberg, but into primitives that allow Iceberg to exist, which is Parquet. Because at the end of the day, most Iceberg tables are just a sea of Parquet files. Okay? Smarter pruning. Things like deletion vectors and Arrow's dynamic pushdowns or dynamic filtering are enabling smarter querying of the data, so that way you're scanning less data, working with less data, so you can more efficiently work with it. Okay? Unified connectivity. Things like ADBC, which acts as a uniform interface, so that way you can connect your engines to your data sources, or the REST catalog interface for Iceberg, which allows your engines to talk to your Iceberg catalog in a universal way, so that way you're not locked into any particular tool, are just growing in adoption. Okay, we'll hear a lot about both of those, and particularly throughout the panel. And again, expand these things, all expanding sort of beyond different formats. So this is where Dremio plays a very special role. It's a contributor to all three of these projects, okay, and a co-creator on many of them as well. And whenever I talk about sort of like Dremio's open source roots here, when I think about all three of these projects, Dremio is one of the first, if not the first, sort of commercial entity to really get behind each of these projects. So these are all now household name standards when it comes to when you think about the Lakehouse. And when people ask me like, okay, hey, how should I build my Lakehouse? So yeah, there's other platforms that use these open source projects. But I can only really think of one company that sort of really led the charge and said, hey, these are going to be the standards, and went all in on them, not when it was safe to do so, but was able to predict where the market was going and where the industry was going as far as the open standards successfully time after time. So wouldn't you rather sort of, if I had to, make a bet with someone who's been making bets successfully for quite a while now, for 10 years. So let's talk more about open source. Let's bring up our panel. First, I want to bring on Dmitry Bolachkov, Senior Software Engineer at Dremio. Next, I want to bring on Matt Topol, co-founder of Columnar. And Jacopo Tagliabue, co-founder of Bauplan. Yay for music. Okay, so super bright. Brightness is good. That means we are moving in the right direction, away from the darkness. I don't know what I'm talking about. But let's start off with just kind of having you guys introduce yourselves and sort of like where you're working on with these particular projects and sort of the spaces that you're focusing on. So Dmitry, we'll begin with you.
Yes, hi. I'm a member of PPMC for Apache Polaris. That's my primary focus right now, advancing the community, welcoming new members. Let's see it grow.
Matt?
So I'm a PMC member on Apache Arrow. I'm a committer on Iceberg. I'm an ASF member. I started Iceberg Go, the Go implementation. And I'm going to keep making fun of you guys because you had your pictures of your books up there for Iceberg. Where was the picture of my Arrow book? I bugged Reed about it in London, and it didn't show up this time.
Well, speaking of that,
I feel there's a bias there, maybe. I don't know.
let me give you a quick follow-up question. What is your book and who published it?
Packed. It's called In-Memory Analytics with Apache Arrow.
Where can people get it?
Anywhere the books are sold. No, but I mean, Amazon, O'Reilly. If you have an O'Reilly subscription, they have a deal with Packed, and you can read it there too. Or you can get it on Packed, Amazon, whatever you want. But it's called In-Memory Analytics with Apache Arrow. Second edition came out last year. It was the first book about Apache Arrow. It's still the only one that's, comprehensive. There was another one written that was focused on R, but this one covers C++, Go, and Python. And, forward by Wes McKinney, co-creator of Arrow, and so on and so forth. And then, co-founder of Columnar, focused on ADBC and database connectivity around Apache Arrow. And I'm still very active in the development space there.
Okay, Jacopo?
So I'm not in the PMC of anything, and but I was the reviewer of the best Arrow book on the market, which we just learned was actually Matt. I haven't written any book that you should read in any meaningful sense. I'm the CTO and co-founder of Bauplan. Bauplan is a data platform that is code first. So we support Python and SQL in a serverless manner. So our customer use Bauplan to, for example, do write-OD publish and go from ingestion to the Lakehouse to cleaning their assets to prepare data sets for training or dashboard serving. And of course, we are totally married to the open Lakehouse idea. So most of our customers actually use Bauplan in conjunction with query engines, such as, for example, Dremio, by leveraging the idea of the zero-copy Lakehouse format through Iceberg. Our company was built on top of Iceberg Arrow and an original project that is also Dremio-based, which is called Nessie. And so, we're super happy to be here and be part of this ecosystem.
Awesome. Okay, so now for our first question, Dmitry, I want to ask you a question about sort of Polaris. What has been sort of like one of the features that have really excited you that have recently been included in a recent Polaris release?
Yeah, well, that tough question if I have to select just one particular feature, but lately I would say, just judging from the community perspective, as you probably know, if people were watching Polaris, it started off as an initial donation that only supported cloud providers like Google, Amazon, and Azure. And recently, the S3 support was expanded to cover custom or on-prem solutions. And I see a lot of interest in both from the user side and from the provider side, like Min.io should be working. Ceph was pretty engaged. NetApp was probably interested as well. Yeah, that was kind of like the most impactful change as far as I can see.
Okay, similar question to you, Matt, but regarding Apache Arrow. What's the newest thing in Apache Arrow that got you most excited?
I mean, there's a couple things there. One of the more recent ones was the addition of the variant extension types. You know, the conjunction of the V3 with Iceberg and getting the geospatial and the variant types in there. The geospatial extensions have existed for a while with GeoArrow, but getting all that into the Parquet format also involved, well, if you're going to have Parquet and Iceberg wants that variant, you need some way of transporting that data once you get it. And so we worked along, the Arrow community worked with the Parquet community and the Iceberg community and very closely and added an extension, and you know, and I authored an extension type that to represent variant data in Arrow. And that enables it so now you can, once you know the various libraries implement support for it, you can then get your variant data type from Parquet all the way to Iceberg, all the way to your application, and it can stay using Arrow data the whole way through, you know, whole 9 yards. And now we just need to wait for, now we just need the vendors, you know, Dremio, Snowflake, and Databricks, and all that return Arrow data to now leverage that extension type and actually return the variant type. And that's the next, you know, so like while I'm excited about having added the support, I'll be more excited when the vendors actually start using it.
Okay. I think like data fusion just, I mean, data fusion is very close to using
Yeah,
it, right?
a lot of, I was working a lot with the data fusion guys, and there was a lot of collaboration back and forth between me and them for implementing the Arrow extension type, because Arrow as a project, you need to have, whenever we make a change to the format, there needs to be at least 2 implementations first before we vote on a change to the format. And so this time it was Go and Rust. For the Parquet implementations, it was Go and Java for adding the variant type to the Parquet one.
Yeah, now Jacopo, a question for you. When we first met, we were talking about like sort of the world of trying to use like sort of like Pi Iceberg and Nessie and whatnot for a lot of these like early stage when like it was the Wild West of like using Python with Iceberg. Now, over the years, what are your thoughts about the evolution of using Python to work for Iceberg workloads over the last few years?
So, I mean, I think like, you know, since the first early days, we're very early betting on Iceberg and Arrow. Like, you know, not as early as Dremio, but basically early compared to anybody else that is on in this room. Yep. And the support was, you know, the only good support was for Java. And, you know, and there's many good things that we can say about Java. If you can tell me one, I can repeat it. But definitely our company was building a new generation on, you know, different type of like, kind of like, you know, philosophy, different type of ergonomics and all that. Sorry, Dimitri, I know we have this feud between us about this. And in the beginning it was rough. Like we, you know, like there was no Iceberg, even REST catalog. So there was not even a concept of like, you know, 2 catalogs being the same. Yeah. Pi Iceberg supported on a very limited amount of catalog. We used to run on a fork of Nessie, again, this Dremio project you may know about. We were the first people to connect Pi Iceberg, which was like very rough, to Nessie, which was sort of rough. And so you have to monkey patch a bunch of stuff to make things happen. And so there was the, you know, the fun days in the trenches. I think flash forward 2 years, those bets were, you know, paid off handsomely. Like, you know, Arrow is now, I think we can say, the de facto standard for all the new system coming up, even, you know, thanks to data fusion, other SQL engine that are kind of like, you know, are based on that. And Iceberg came from a sort of niche thing to something that is behind billions and billions of dollars of investment from basically all across the spectrum in the data community. And correspondingly, even the Python support got better. I wouldn't say that it's still perfect up to this day, so there are still a few things that probably could be slightly better. But also Bauplan got better, and so we're way less relying on sort of on that specific piece of the puzzle, and so we're kind of less impacted by that. But you know, seeing the ecosystem evolve in the last 2 years has been kind of like an impressive story of, you know, community coming together and kind of like helping each other out in a sense.
Okay, cool. Now, I have a question for the audience, just to make sure that we're, you know, as far as how we're all talking about. So I want to just do a show of hands. Raise a hand if you're saying yes. Don't raise your hand if you're saying no. The question is, did Matt Topol write a book? Yes, okay. So
two editions, by the way.
Two editions, yes. There was a new edition. That was like earlier this year, right?
Last year.
Last October.
Okay.
Time flies by. Okay.
Yeah, considering that the first edition was 3 years ago now.
Yeah.
You know that your book is a mandatory reading for everybody that I read about.
You've mentioned, and I love it. It makes me happy.
So, get the book. Now, Dimitri, tell us like a little bit about like.
I did not pay him to do that, by the way.
No. No, but Dimitri, you basically you've worked on multiple Apache projects, whether it's working on with Polaris, working with Iceberg. Sort of, can you tell us like some of like what are the things that make it different when you're working specifically with like an Apache project versus like sort of other types of open source projects?
Well, Apache is all about community, right? So that's the critical thing. That's where people get together and share ideas and work out something that works for everybody. I think that right, Matt?
The motto is community over code.
Exactly. Yeah. Just having a good interpersonal collaboration. That's the key thing in Apache. That's what makes it move forward.
Have you guys ever seen a situation where collaboration wasn't what you ideally wanted?
Oh, always. I mean, just because it fosters good collaboration and the communities that are fostered under the Apache ecosystem are generally, really good communities, doesn't mean that there aren't situations of drama that come up. It's tech. That's there's going to be drama. Like, it's just what happens. So there's been plenty of things over the years that have had, but because of the way that the ASF is structured, and the way that the projects are managed, and the way that the community works, those types of situations don't end up, they don't take down the project. Like the community is able to recover from something like that. Usually, when there's a big like schism or problem with a project, you usually just end up with a fork.
Okay.
But there's a lot of mechanisms baked into the culture of how the ASF works that really make it fundamental in keeping the community together and fostering the collaboration, even when that collaboration kind of is uncomfortable for a little bit, it still continues. We still pick back up.
Now, a question for all three of you. Sort of right now, if you were to say, hey, sort of like over the last couple of years, like the Lakehouse sort of like edges. So if anyone implemented like a Lakehouse a few years ago, where there's like a lot of rough edges that you have to kind of figure out and kind of tinker around to kind of get to work, a lot of those have been really smooth, and it's a lot smoother and much easier, especially after today with the Dremio Next Gen Cloud. You can literally just sign up and have a Lakehouse in a few minutes. But if you were to think about sort of like what are sort of the edges that you would like to see smoothed over in implementing Lakehouses over the next few years, what are some of the ones that sort of come to mind?
I mean, we build this kind of like serverless code first Lakehouse. So interoperability is top of mind for us because we're responsible for a specific part of our customer, maybe the biggest part in terms of compute, but it's still like a specific part of the entire ecosystem. Like they're gonna have ingestion before us, like I don't know, a Kafka or Fivetran or whatever, and they're gonna have maybe query engines after us. So it's important, in both directions. We're kind of like zero copy efficient, and we don't duplicate any work. And that's the dream of the Lakehouse. And I would say that 2 years ago, the dream was like, if you imagine like a completion bar, it was like, maybe 10% was mostly marketing slides. And now we're maybe, I don't know, 50, 60. I think we're much better, but we're still very, very far from a seamless experience. An example, without naming names, but like an example, there's like ingestion tools that you can use to take your Postgres into Parquet files in your Lakehouse in Iceberg, and they work, and that's fine. And then you import into Biplan, one command, it works. Biplan creates an Iceberg table. You can run your transformation there, and then you pass this table to a very large cloud provider that ends in Lake, and then you ask them to create a table, and they do because they see the Parquet file. But then when you query, it turns out that they can only query a specific type of timestamps in milliseconds, right? So there's a physical representation of a logical type that doesn't have any guidance on how to do that everybody else implements in one way, and then one provider implements in another one, but the customer kind of figured this out at the very end when they run the query. And so this thing still happens today. This thing happens today, and I think that's why I think it's 60% or whatever, but I think it's a bit, it's gonna take a bit more of this rough edges, logical type, physical types, arrowing, JDBC, ADBC, all these things to get to a point where maybe 80, 85, so the default is working, and then there's always going to be a long tail of stuff that sort of, that's the life of data people. Yep. The long tail that kills you. So yeah, so I'm not, I'm old enough to be cynic about this. There's going to be a long tail, but I think the 80% should work out of the box, and so halfway there. That's my experience.
Matt?
I would say the biggest rough edge right now, not just because it's the space I'm in, but the biggest rough edge right now is the connecting to your data sources. It's, everyone, over the last, decade, we focused a lot on separation of compute, separation of storage. We focused a lot on the query engine and cloud storage and Iceberg and stuff like that. And now all the agentic AI stuff. But the thing that's always kind of fallen by the wayside is the actual act of retrieving your query result data from your data source. And you have, a giant mix of different client protocols. You've got, but we also still rely on these ODBC and JDBC that were built in the early mid-90s, that are all row-oriented, whereas all of our analytics stacks are column-oriented, and then we want to throw them into data frames, which are also column-oriented, which we want to throw into visualization things, which are also using column-oriented representations. And so you have this disconnect where you're serialized, where we're taking column-oriented data, serializing it and transposing it into rows, and then transposing it all back into columns just because, well, ODBC is what you do, right? And so, getting that adoption of, in this case, ADBC, what I'm trying to say, but getting the adoption of column-oriented protocols at the connectivity part. Iceberg is unifying that storage layer, but we don't have anything that unifies that top, connectivity layer yet until ADBC, which is, anyone catching the pattern there? but so like that, but that's still the rough edge. It's because it's not fully adopted yet. Not all the vendors support an ADBC driver. Not all the vendors, even if their internal stuff is all column-oriented, so many cloud compute engines, the only output they support is JSON. And it's like all column-oriented compute, but then they only give you JSON. It's like, okay, what if I wanted a lot of data? Well, the only solution, it's like, well, don't want a lot of data, or just write Parquet files. It's like, but what if I just want to stream a lot of data? Can you give me a binary format that's column-oriented? So there's
Binary
a lot.
JSON?
Don't get me started. No. BJ's, BSON, no. And then so that extends to all of the agentic stuff. You have MCP servers. The communication is JSON. And we want all of these agents to be able to communicate larger and larger context windows. We want all these agents to be able to communicate and find this large amount of data. How are we going to do that efficiently if the way that they communicate is inefficient, very large JSON blobs, as opposed to compact, binary, Arrow, or something else that would be much more efficient ways of transporting that data for an MCP server? And so that's kind of boils down to my goal and what I want to do. An ecosystem is smooth over that rough edge of that communication, that interoperability. The ecosystem is, coalescing around Arrow as a de facto standard for transport.
Got it.
Let's keep that going all the way through the stack.
You want to get all the data off buses and onto jet planes so they can get around faster.
Yeah.
Yep. Cool. How about Dimitri? How about you?
Yeah, I would say maybe optimization is something that may be not so obvious, but if you think about Iceberg tables that give you a nice breakdown into snapshots and metadata files, if you're ingesting into that and you want to optimize at the same time, there comes a surprise that people may realize only too late, where you just have two concurrent updates to the same table, which doesn't happen very nicely in most situations. So then you have to deal with, and I guess a lot of users are basically left to resolve that problem by themselves. So I would hope that some kind of maybe a uniform or a common solution is going to be found later, because that's an important gap. I would say maybe a rough edge as well, that especially as more streaming jobs appear, it becomes pretty critical in my opinion.
Agreed.
Yeah.
Okay, so now let's do the flip side of that, and let's talk about sort of what has got you excited. Now, when we take a look at this coming year in these projects, whether it's Iceberg, Polaris, Arrow, what are things that you are excited to see far as proposals that they haven't quite made their way into the code base yet, but you're hopefully this year those proposals will go through. What's got you most excited? I'll let you go first, Dimitri.
Okay, I have two at least, but I can take turns. I would say FGAG is pretty cool. There is a proposal going on in Iceberg about that, and it's basically defining a common standard for fine-grained access control that could be shared across different engines, could be implemented in a way that is interoperable. That's a pretty cool feature. I would like to see how it develops.
Now, actually, I'll follow up on that, because one of the questions, and me and Matt were talking about this earlier during the Q&A panel, as far as like the representation of how do you represent those FGAC rules. Do you have an opinion on that?
Are you asking me?
I'll ask you both of you. I'll if you have an opinion on this.
I can answer for Matt.
I'm waiting for somebody to figure it out so that I can just steal it and just use it. I don't have to.
Perfect.
I mean, my opinion is don't use SQL.
Yeah.
Because then you're going to have the fight over, okay, which dialect, and which semantics, and which this, and which that. Use some sort of intermediate representation.
Which generally the options would be calcite or substrate. Do you guys have a preference?
Well, actually, another popular one lately has been DataFusion's DataFusion's internal plan representation has become popular for a lot of things. For example, DBT SDF adopted it for a lot of their internal lineage, and also for their their conversions of all the different dialects that they were doing.
Like as a standard
SDF. They standardized on using Apache DataFusion's internal query plan representation as that was their intermediate representation. So like calcite, substrate, DataFusion. Like the point is use a query plan as your representation, not a raw SQL query. And the couple of reasons between the arguments over dialects, but also if you want to have a Iceberg client and not have to have a heavy SQL engine with it, you need to be able to evaluate these FGAC rules without needing to execute SQL.
Understood.
And Dimitri, you...
Yeah, you stole it from my mouth pretty much. But I would say, like, Iceberg Go implementation and Iceberg Rust, they become pretty complete now by now, right? And these are new things, so maybe I'm still
missing a bunch of the V3.
Where like
the V3 stuff still.
A couple of years ago, Spark was pretty much the only open source.
It was the old J of the jar.
And then SQL comes natural, but now it's actually a thing to think about, right?
Yeah, I mean, there's a reason why people want to use Iceberg without a JVM.
Now, Matt, the thing you're most excited about for the next year?
I have two. There's
do the first one, and then we'll go back to you and Dimitri for the second one.
I mean, the first one is the Parquet. The Parquet community, one of the long problematic pieces of Parquet is wide tables and the size of the metadata. And essentially, the more columns you have in a Parquet file, the longer it takes to deserialize the metadata. And why that matters is the entire purpose of things like Parquet is column pruning and statistic pruning and things like that for row groups, which means that if I want to only read one column from the Parquet file, it's all designed so that I can just read one column and read just the data for the one column. The problem is that since it's using a technology Thrift for the metadata, I still have to deserialize the entire metadata for all of the columns. That includes the statistics, that includes the counts, and for all of the columns, even if I only wanted to read one column. And so the Parquet community is trying to address this, and what they're looking at is different ways of representing and storing that metadata that's backwards compatible, but is forward-looking with things like flat buffers and other things like that to allow much more efficient managing of that metadata, so that you can get much faster access and handling on wide Parquet files with 10,000 columns or whatever.
That's actually pretty cool.
Didn't Andrew? Sorry, I saw some. So Andrew Lamb, I think this is already implemented.
They have a proof of concept. There's a POC.
There's a POC.
So there was a proposal on how to do it. there's a POC, and then they started benchmarking and testing.
Yeah,
POC.
it was bragging
it's
privately
not,
about it was bragging.
It's not
broad. It's not broad. Yeah,
it's not fully agreed by the community yet. In that being the standard thing, but the POC looks very promising.
Yeah, that's very cool.
Jacobo, what you're most excited about?
So we again, most of our customers runs Iceberg, and I think there's a common, as all of you know, Iceberg has been great for many things, but I think it kind of became maybe too popular too quickly for its own good in the sense that the original design, there was an improvement definitely over I, but still has a lot of issue when you think about a bit. If you could sit down and think about it like for a while, I think a lot of database people have a lot of complaints about that, and I think it just takes a while for the community to catch up on this and make it better. So for example, the prevalence of small file, all these manifest, all these tiny files that you need to open and kind of like reads to just get 5 rows out of my table. There seems to be a lot of overhead, right? And I'm very sort of looking forward to the new structure of the metadata and all of this improvement that is gonna bring. One thing that I haven't seen much, and maybe this will come, would be a fully open source and pluggable implementation of RBAC and credential vending and all of that. What I mean is that, of course, I can download Polaris or other stuff, but it is tied to Polaris. That thing, again, is Java. It works but there's no reason for that to be the case. There's a total possible world in which you have a library that you can plug in with just a standard interfaces, and it will give you the standard RBAC thing, which are the 4 things that we need to do. They're not like rocket science, but for some reasons, everybody ends up reinventing the wheel. Even in the composable data system movement, which were great prominent of hey, you don't need to reinvent a query parser, you don't need to reinvent a query engine, you don't need to reinvent blah, blah, blah. There's still no open source, pluggable, decent solution for basically RBAC and credential vending, which is, I believe, still a bit weird. So, this is more me raising a challenge with the community. It's why that's the case? That seems to be way more important than 95% of V4 improvements. And they will, really democratize the access to this for people, going back to Matt, that they don't want to have maybe a JVM attached to them. For people, they may not necessarily use SQL. Would it be nice to just have a library that I can use from Python to do RBAC control and to have a data frame back? Why not? But as of today, this thing is just like a sci-fi fiction.
So you mean you'd have a library that actually runs the rules and makes the decisions?
Yeah,
there's some generic stuff for rules and stuff. I think AWS has one called Cedar maybe or something like that. But something that is specific. You don't have to be so generic. You don't have to be like a YAM role type of thing. At the end of the day, a database or at Lakehouse, there's a few things. There's table, there's column, there's rows. And I don't want to simplify too much. But at the end of the day, it's a very understood use case. Would it be nice to have a library or a client server thing? But it's just really encapsulated wrapped nicely in a few things that I can then hook up into my own catalog or my own system in a way that doesn't depend on me buying in the entire Polaris or JVM ecosystem. I think that's a hole in our composable data system kind of manifesto. And I think this will actually be more important than many marginal improvement of Data Fusion Query Optimizer for enterprise adoption. You know what I mean?
So yeah, and one thing I just want to point out, as far as you mentioned earlier about the small files and things like that. So there is a proposal for V4. So for those who were there in the presentation, they already heard me talk about this. But the idea is that in the next iteration of Iceberg, so think 18 months from now, so because V3 just got approved. But the idea is one of the proposals they're talking about is trying to figure out how can you have commits that only make 1 new metadata file instead of a dozen new metadata files, depending on what that is. And that's particularly sort of interesting for things like streaming, where when you're doing a lot of frequent writes in very short bits, if you can eliminate some of those files. So those are some of the interesting proposals that are coming down the pipeline for Iceberg. One that definitely I'll point out. But I remember that Dimitri, you had 2 things.
Yes, thank you for coming back to that. Yeah, and actually it connects to what Jacopo was saying about credential vending. Another interesting thing happening in the Polaris world is a proposal for an extension of the API to access data, right, to access tables, because as we saw many examples today, Iceberg is not the only data that you're dealing with. You have PDFs, you have all sorts of unstructured data. And it would be interesting to see a catalog supporting, controlling access and rationalizing access to those data files as well. And as a natural extension, it would be, well, credential vending could be supported as well. Yeah,
It'd be great if all the clouds could actually, you know, agree on how their credential vending would work.
Oh,
so
yeah.
that would do like enormously different things for every cloud to get credential vending. But that's a different problem.
But at least if we can get it to work across different formats, that would be a big achievement already.
Yeah,
That's fair. But even S3, isn't S3 S3 is in object storage?
GCS, S3, and Azure and ADLS, all three of them have an entirely different set of API calls that you have to do in a different way to do a credential vending. So anyone trying to implement an Iceberg REST catalog and do credential vending,
they need to do all three.
They need to implement, they need to re-implement or use libraries or whatever for all three, and there's no really reusability about it.
Going back to my point.
But Matt, you had a second thing?
Yeah, the second one I was, my other big exciting piece is with ADBC, one of the big proposal that we're trying to put through is asynchronous APIs.
Okay.
You know, right now it's the API itself at the low level is very synchronous. It's, you know, it's pull oriented. You know, from the consumer side, you have to pull the data and handle back pressure that way, and it makes it slightly more difficult to interact with if you are a system that is heavily utilizing async await API style programming. And so there is currently a proposal that's being worked on that we're trying to clarify and work out for asynchronous APIs on a new iteration of the ADBC API, so that we can then incorporate that with, you know, the Python bindings, the Rust bindings, and things like that, and provide a better support for those async await use cases.
Got it. Okay. Well, we're kind of getting to the end of time. So what I want to do is just go a quick around and remind everybody who you are one more time. Where can they learn more about you and follow what you're doing? And yeah, so go for it.
Yeah, Dmitry from PPMC of Apache Polaris. It's pretty easy, polaris.apache.org. The website has a lot of information, and new contributors are always welcome, even if you just want to use the project, right? There are examples. Give it a try. If you see some rough edges, you know, comment, send an email or Slack to the community. We're always happy to see new people getting engaged and you know, just see the project grow.
Matt Topol, you know, arrow.apache.org if you were interested in the Arrow project and all of that, and the numerous implementations. We're looking for variety of contributors for like anything ranging from better documentation to JavaScript and TypeScript support. Like, there's lots and lots of things people can contribute there. Iceberg, obviously, is icebergapache.org. And if you're interested in following more of what Columnar is doing with ADBC and things, columnar.tech. And you can always find me on LinkedIn or at these types of events, because I come around to a lot of these things.
Cool.
Jacopo Tagliabue from Bauplan. My name is impossible to spell, so you can either take a picture or look at the speakers, and then you can find me online. If you can Google, there are two Jacopo Tagliabue on the planet. They're both doctors. One of them is a useless doctor, which is me. The other one is a real doctor, actually cures people. So you can just find me, and from there you can go to, you know, all of our open source work, our papers. We are kind of very active in the scientific community, both in data and the iSpace, and of course.
You write useful things.
Yeah, you write useful things. Yes. So I think a more charitable thing is, like, I put my name on things that people write. They're useful. And you also find me.
Don't say that part out loud.
I know. I mean, it's like, yeah, now the cats are back. Like, I'm not as, you know, as fun as Matt, but I'm also, you know, you can find me around in data events here and there. I'm very easy to reach on LinkedIn. I'm always, jokes aside, I'm always happy to geek out on data management, Lakehouse, Arrow, Iceberg. And if you want to know more about Bauplan, please let me know. Okay. Thanks, Alex.
Cool. No problem.
Thank you very much, Alex.
A quick round of applause for our panelists. Woo. So before I head this back off to Reed, remember we walk away with this with sort of two assignments. One, make sure you sign up for the Dremio Next Gen Cloud Trial. And two, I guess get Matt's book, which is a good book. It's a very good book.